Hello friends, now we are left with the last circuit, that is current repeater circuit in compound circuits. Current repeater circuit is an extension or an application of current mirror circuit. The circuit you are seeing here is a current repeater circuit where instead of using single transistor on this side, we are using n number of transistors in the current mirror circuit. We are not using in normal current mirror circuit, we have only two transistors, Q1 and Q2. Instead of Q2, here we have multiple number of transistors on that side. Fine. So see it carefully. The base of this is connected to the base of the next stage, then this is also connected to the base of next stage, and so on. If you have n number of stages, then it is collected like this. This is just an extension of current mirror circuit only. Now let us see it carefully. What is current in this path? This current is IB1, this current is IB2. Current here is what? Sum of this current. This is IB3. Current here will be, and so on. Current here will be IBN. So the current here will be IB3 plus IB4 and so on plus IBN. Current here is IB2. So current on this side will be IB2 plus IB3 plus IB4 and so on. So if you see this, if you apply KCL here, this current plus current going on this side will be equal to what? IB1 plus IB2 plus IB3 and so on up to IBN. If you apply KCL here, so say this is C1, applying KCL at node C1. What do we get? IREF is equal to IC1 plus IB1 plus IB2 plus so on plus IBN. This is what you have. This current will be algebraic sum of this current plus all these currents. These are what? The sum of all the currents going this way and this way, right? We are simply applying KCL in fact. But there is assumption here. Assumption is what? Assumption here is all transistors, all BJTs you can say, all transistors are identical or matched. Identical or matched. If all transistors are identical, then IC1 will be equal to IC2 will be equal to IC3 and so on, that will be equal to ICN. Similarly, IB1 will be equal to IB2 will be equal to IB3 and so on, that will be equal to IBN. And beta 1 will be equal to beta 2 equal to beta 3 and so on equal to beta, and that is the gain of transistor, right? Voltage here will be nothing but VBE. So I am assuming VBE1. Of course, all are, if you see, all the node, this node is common to base of all and ammeter is connected. So VBE1 is equal to VBE2 and so on, that is equal to VBN, and that is VBE, right? This is equal to IC, this is equal to IB, this is equal to beta, this is equal to VB. If you have this set of assumption, why I am assuming? Because I am assuming all transistors are identical here. Now in that case, IREF will be equal to IC, because IC1 is equal to IC, all currents are equal. Then IB plus, if you add IB, how many number of times? N number of times. So this will be equal to N into IB. That's it. But we know what is the relationship between base current and collector current. The base current is equal to IC upon beta. So this gives IREF is equal to IC plus N by beta into IC. Or further I can write IC equal to what? That is beta by beta plus N into I ref. So you can find the collector current if you know the I ref, right? So now see it carefully. If you, what is the voltage at this node? VB, because this is ground. If this voltage is VB, so voltage at this node will be what? VBE. So what will be this current? This voltage minus this voltage divided by this resistance, right? So reference current IREF will be equal to VCC minus VBE divided by RREF. So that means I can find the collector current of each stage. Collector current of each stage will be equal to this. So this is one simple expression of the current. Fine, but remember one thing, I am assuming n number of transistors including this. Fine. Similarly, if you can have n plus 1, you can have n plus 3 and so on. In my textbook or in my text, if you make it Q, if you make it Q1, if you make it Q2, and if you make it Qn, then what will be this current? This current will be IB1, so this will be IB plus IB1 plus and so on. Fine. Or you can say if it is Q1, it is Q2, it is Q3 and it is Qn plus 1. Last transistor Qn plus 1. It means number of transistors are n plus 1. So simply replace it by n plus 1. Fine. If it is, suppose you have 3 transistors, 3 means n plus 1. So what is n? 2. So it will be simply 3 here. N plus 1 will be 3 here. And so on. What I mean to say is you can find the expression of the collector current depending upon the number of stages. If it is on right side, if it is n number of stages, it is n plus 1 here. On right side, if it is n, on right side, if it is n plus 1, then how many stages are there? 1, 2, 3. It is n plus 1 including this. So how many are there? N plus 1. So it is n plus 1 there. If we have 2 transistors on this side, so in place of n plus 1, it will be 2 here. So whatever is the number of transistors on right side, that figure will come there. Fine. So suppose you have 3 transistors in total, so it will be 3, 1, 2, 3. So if you have 3, suppose you have 1, 2, 3, 4, so it will be 4 here and so on. So number of transistors directly will be placed here. If it is 2, let it be 2. If it is 3, let it be 3. If it is 4, it will be 4 and so on. Fine. So that is how you can, but you don't need to mug up the formula. Just remember the procedure. There was one question based on this concept, this circuit, that was in gate. The question was of course based on the current repeater circuit. Let us see that example. Let us draw the circuit first. The circuit was, you were given the circuit like this. The circuit was, we had a resistance, a transistor like this, which was grounded. Then there was transistor here. Then there was one transistor on this side. Both were kept common. There was a voltage source of 10 volt. There was voltage source of 2 volt here. This was 1 kilo ohm. Fine. And both of these were again connected to ground. So, and this was connected to base terminal were connected to collector, and this was connected to base. This is just different orientation, and this resistance was 1 kilo. This is just different orientation, and the question was you had to find the voltage VC. This is voltage VC. Question was find VC. Fine. And one thing was given to you, Q1, Q2, Q3. Q1 find VC if Q1, Q2 and Q3 are identical. That was given to you. Now please see this circuit. This circuit is this circuit only. The only thing is they have changed the orientation of this BJT. Otherwise it is this circuit only. You can remove this and just change the orientation of the circuit, that becomes this one. Fine. So here, what is this current? This is IC. What is this current? IC2. This current IC3. But since transistors are identical, this is IC, this is IC. So what will be current here? 2IC. Fine. And let us see that what is current here. This is, this side it is IB, this side it is IB, and this side it is IB. So if you apply KCL at this node C1, so this is IREF. So IREF will be equal to what? IREF will be IC plus what will be current on this side? This side we have IB, we have IB this side, we have IB this side, so this is 3IB. So IREF will be equal to this current plus this current, so IC plus 3IB. I repeat, I am just simply applying KCL at this node. If you apply KCL at this node, what will be this current on this side? This current plus this current plus this current. This current is base current of this. This is IB, this is IB, so current here is 3IB. So if it is IC, if it is 3IB, what will be this current? This current plus this current, that is what you have. Fine. Now we know what is IB, IC by beta, and beta is also given to you. Beta is given to you. Beta of each transistor is 100. That's given to you. So this is IC by 100. So IREF will be equal to what? IC plus 3 by 100 IC, or this is equal to 103 by 100 IC. So what will be IC? IC will be equal to 100 by 103 into IREF. And you know what is IREF? You please see the circuit. Voltage here, up from here to here is VBE. So voltage at this node is VBE. This is connected to this. So voltage at this node is what? VBE. Fine. So this voltage minus this voltage will be voltage difference across the resistance of 1 kilo ohm. So this voltage is 2 volt minus this voltage is VBE divided by this resistance is 1 kilo ohm. So that is 1000. So this is 2 minus 0.7. Why? Because voltage VBE is not, that is also given to you in the question. VBE is also given to you, that is 0.7. So that gives you 1.3 by 1000. Fine. So IREF is this much. So this gives 100 by 103 into 1.3 divided by 1000. That is IC, that many amperes. And we know what is this current to IC. So VC will be equal to, this voltage will be equal to what? This voltage minus voltage drop across this resistance. So 10 minus 2IC multiplied by this resistance is how much? 1000 ohm, right? So this gives 10 minus 2 multiplied by IC is what? 100, 103 into 1.3 divided by 1000 multiplied by 1000. Fine. That is what you have. This 1000 and 1000 is cancelled. This is 1.3 by 1000, 1.3 by 1000. This is cancelled. Fine. So this gives 10 minus 200 multiplied by 1.3 divided by 103. That is voltage VC. And the value of the voltage VC here comes out to be, that is 7.47 volt. So this is 7.47 volt. You can just verify this value. Fine. So that is how the question could be solved. That was the question based on the current repeater. That was question in instrumentation engineering, but of course there can be question in electrical or electronics based on this current repeater circuit. So this is all about current repeater circuit, and that finishes the chapter of compound circuits. These are the circuits which we have already discussed. What we discussed? We discussed the cascade connection, we discussed the Darlington pair, we discussed the cascode connection, then current mirror using BJT, current mirror using MOSFET, then Wilder current source, and the current repeater. These are the circuits which are placed in compound circuits. So that finishes the chapter. In my next video, I will be starting with the next chapter, that is feedback amplifiers. So wait for my next video. Thank you very much for watching the video.